Welcome! I am Teacher M. This math tutorial video is focused on limit properties. If you are interested to learn more about this topic, stay and watch the entire video. In this limit properties video series, 8 limit properties will be covered for the entire series. These are constant, identity, scalar, sum and difference, product, quotient, power, and radical property of limit. For this 8th episode, the video is focused on the radical property. Before you continue to watch this video, it is advisable to learn first the following properties: constant, identity, scalar, sum and difference, product, quotient, and power property. Radical property states that the limit of the nth root of a function is the nth root of the limit of a function, where b and c are real numbers, n be a positive integer, and f and g be functions with the following limits, L and M. To understand it more, let's do this example. What's the limit of the square root of x as x approaches to 4? By applying the radical property, it becomes the square root of the limit of x as x approaches 4. By using this property, it allows us to take the limit of the function inside of the radical before performing the root. In this example, x is the function inside of the radical. Next, the limit of x as x approaches 4 is 4 by identity property. Then, take the square root of 4. We can conclude that the limit of the function, or the limit of the square root of x as x approaches 4, is 2. To further explain this property, let's have another example. What is the limit of the cube root of the difference of 2 and 3x as x approaches 1? I'll give you 5 seconds to think whether to pause this video and give it a try or continue the video. By applying the root property, it leads us to the cube root of the limit of the difference of 2 and 3x as x approaches 1. This property lets us to take the limit of the function inside of radical, which is the difference of 2 and 3x. To continue, rewrite the radical and take the limit inside using the sum and difference property, which is the difference of the limit of 2 as x approaches 1 and the limit of 3x as x approaches 1. Rewrite the radical and the limit of 2 as x approaches 1. Apply scalar property to the limit of 3x as x approaches 1, which makes it the product of 3 and limit of x as x approaches 1. Rewrite again the radical and take the limit of 2 as x approaches 1, which is 2 using the constant property, and subtracted it to the product of 3 and the limit of x as x approaches 1, which is 1, using the identity property. Simplify the expression inside of the radical, and the result is cube root of negative 1. Take the cube root of negative 1. Thus, the limit of the cube root of the difference of 2 and 3x as x approaches 1 is negative 1. Last example. What is the limit of the square root of the quotient of 4x and the difference of 3x and 6? I'll give you 5 seconds to think whether to pause this video and give it a try or continue the video. By applying the radical property, Take the square root of the limit of the quotient of 4x and the difference of 3x and 6. In this example, the inside function is the entire quotient of 4x and the difference of 3x and 6. We write the square root and take the limit using the quotient property. It becomes the quotient of the limit of 4x as x approaches -1 and the limit of the difference of 3x and 6 as x approaches -1. We write the radical and the numerator. Focus on denominator. Take the limit using the sum and difference property. We have the difference of the limit of 3x as x approaches -1 and the limit of 6 as x approaches -1. Copy the radical and apply scalar property in numerator. It produces the product of 4 and limit of x as x approaches -1. Apply similar property in the denominator, specifically to the limit of 3x as x approaches -1. Then, we have the product of 3 and the limit of x as x approaches -1, and subtracted it to the limit of 6 as x approaches -1. We write the square root. In numerator, we have the product of 4 and the limit of x as x approaches -1, which is -1 using identity property, over the product of 3 and limit of x as x approaches -1 is -1 using identity property, and subtracted it to the limit of 6 as x approaches 6 is 6 using constant property. Simplify the expression inside the radical. The product of 4 and -1 is -4 over the product of 3 and -1 is -3, and subtracted it to 6. Simplify denominator by getting the difference of -3 and 6, which is -9. A negative number divided by a negative number is a positive number. Inside of the square root becomes a positive, which is square root of the quotient of 4 and 9. Take the square root. We can conclude that the limit of the square root of the quotient of 4x and the difference of 3x and 6 is 2/3. This is how to apply the radical property and other properties such as constant, identity, scalar, sum and difference, product, quotient, and power properties of limit to find the limit of a function. May this series help you to understand the limit property and how to apply it properly. If you learned on this video, hit the like button and subscribe to be updated and notified for other math lessons. See you!